So now we're going to try to simplify by multiplying by a common denominator. And here's what we're going to do here. So in this particular case, notice you have two fractions, but the denominator of the fractions are different, right? So in order to make this work, what we want to try to do is get these to a common denominator. And here's why that this is important. Let's take our example earlier. We had 1/2 divided by 3/4. Notice here that 2 and 4 we can get them to a common denominator of 4 by multiply this top one by 2. And so I can get that to be 2/4 is equal to 3/4. Now, when this happens, these 4s are just going to cancel, and I'm left with 2/3. Essentially, what happened was you took 2 4s again. You took that bottom fraction, you flipped it, became 4/3. And notice that these cancel, so you were just left with 2/3. So this is just a quicker method to do this. So your first step here is going to be to find the LCM between the numerator and the denominator. So in this case, look at 12 and 15. Their LCM, they both go to their common factor. 12 is 4 times 3. 15 is 5 times 3. So they'll both go to 60. So we need to get them to 60. So we'll multiply this one by 5. And then multiply 15 by 4. Right? And so here's what happens when I do that. I get 5x plus 15, because I multiplied everything in the top by 5, over the common denominator is 60. The bottom, I'm going to multiply everything by 4, over 16x minus 20. And again, that's over 60. Notice this, they both have the same common denominators. So I'm left with 5x plus 15 over 16x minus 20. Now, at this stage, I can go ahead and factor things out if I want to factor. So notice that 5x plus 15 has a 5 in common, so I'll factor it out. That means I'm left with x plus 3, because I want to see factors in the end. And over here, 16x minus 20. 16 and 20 both have a 4 in common. So I'm left with 4x minus 5. So this is the simplest form of how to write that using that particular method. Now, look at the next one then. So the next one, now I need to get a common denominator. So the top, notice they both have an x minus 4, and this one has an x. So the first thing I need to do is find the LCM. So x minus 4 and x is going to have x minus 4 and x in both these terms. Notice that this term is missing the x. This term right here is missing the x minus 4 and the x. So we need to get that to both of those. So I'll get this, 3x minus, and then realize that x minus 4 times x is just x squared minus 4x. I'm going to multiply that by this negative 2. So it'll be a negative 2x squared plus 8x over the common denominator, which is, or the LCM, which is x times x minus 4. Bottom already has both those factors. So what I need to do is simplify to get what it's missing. So this one is missing the x term. This one is missing the x minus 4 term. So I'll get this when I do that. I'll get 2x minus, and look, it's just it's negative 1 times x, negative 1 times negative 4, positive 4, all over x times x minus 4. And so again, notice, same denominators, we can cancel them out. So here's what I'm left with on the top. I'm going to rewrite the top a little bit to make it look in a standard form. I want that x squared to be positive, so I'm going to change signs on that. And if I change the signs, I'm going to change the signs for everything up here. So that top will become, that negative 2x squared becomes a positive 2x squared because it leads now, minus 8x plus 3x at the top, over, and again, I have 2x minus x plus 4 at the bottom. So I'm cleaning things up. These will clean up nicely. So this is equal to 2x squared minus 5x over, you have a 2x minus x is a x, right? Plus 4. If we can clean up anything else, we will. Notice that 2x squared and 5x, negative 5x have a x in common, so I'll pull it out. So I'm left with 2x minus 5 over x plus 4. Here is the final simplified answer of this. And again, this process works exactly the same way as the other, except instead of going through and flipping first, we're going to find the LCM in numerator and denominator. Then we're going to cancel the denominators of both, because now they're the same. And then you're going to make sure that you multiply by the LCM.